Hello friends, it's Uncle Sammy again. The last class we talked about variable separable. This time around, we'll be talking about exactness, let me say exact ODE and the integrating factors. Um, so let's start this. So the topic for today is exact ODEs, then integrating factors. So that's the topic. So in cases whereby we have our ODE to be in form of, let's say m, which is a function of x and y, dx plus n, which is also a function of x and y, dy equals 0. It's called exact if the function is in such a way whereby when you find your dm dy and your dn dx, if they are equal to each other, then you say they are exact. So let's say the f dx equals what? M, the function of x and y, and the f dy, which is n, is a function of x and y. So for you to check, okay, so the f equals what? M dx plus n dy equals 0, which makes f a constant. So therefore, you might not really understand what we've been explaining here, but what we're just trying to say is for you to find the exactness of an ODE, you need to check if your dm dy equals to your dn dx. So to check for exactness, or maybe to verify, then your dm dy equals dn dx. So if you're given an ODE in this format, right, what you just need to do is differentiate these with respect to the other side, which is having the y as the differential, and then you differentiate this n with respect to the x. So it's like you're doing it in an inverse way to say. So you have your dm dy, then dn dx. Yeah, so that's how to actually test for exactness. And how do we use integrating factor? Because the topic here is saying exact ODEs, integrating factor. And so how does integrating factor come in? How does it come in? Is that there are some times you try to find if your equation is actually exact and it's not exact. So once you have it in a form like this, but you try to find if it is exact or not, you're not getting the hem dy to be equal to the hem dx, then it's not exact. Then that's when the integrating factor comes in. What is integrating factor? Let's put it that way. What is integrating factor? And integrating factor is a function, or let's call this, sometimes some textbook use IF, but we're using this mu as a function of x and y that you multiply the entire ODE but to make it exact. So what we're trying to say is that if you try to find the exactness and you're unable to get the hem dy to be equal to what the hem dx, then you find the integrating factor that be able to multiply this equation with, and by the time you find your dm dy and dn dx, although you might need to change this to like p and q instead of m and n. So at the point of you trying to find the integrating factor, your m will change to p, your n will change to q. Then you find the p dy as then your dn dx is going to be the q dx. So once they are equal, after multiplying with the integrating factor, if you're able to get this, then you know that they are now exact. So which means you're able to get an integrating factor that is able to turn your equation that is not exact initially to an equation that is now exact. So that's the essence of having of having integrating factor. Then so then to find, so let's just say, so how do you find the integrating integrating factor? So how do you find the integrating factor is simply by, okay, so you call this I have, or you can just call it this, so this is integrating factor, or you call it mu, right? Some textbook will use mu, some will use I have integrating factor. Sometimes you find the integrating factor, they are function of x or they are function of y. So for example, so it's a kind of testing stage actually. So these are the steps on how to go about it. You need to find r, which is 1 over q dp dy minus dq dx, whereby r has to be a function of x. So if you try to find this, changing m to your p, changing q to your changing n to your q, and you're able to get this, and you notice that all your functions are either constants or or has a coefficient of x, then you know that this equation is right. Then you'll be able to use this equation. Then you put it into your integrating factor equation, which is exponential integral rx, then put your dx. So let me go back again. The step is that once you want to find your integrating factor, you need to test in two ways, but this is just one part of it. You find your rx, which is 1 over q dp. So this is the formula you use for finding rx. But after getting your answer, you need to make sure that all the values there are functions of x. It's either they are constant or x for you to be able to put it into this equation. Then you find your integrating factor. So let me go to the second step. In case you're unable to get a function of x, then there's another one to use for function of y. So when integrating factor is a function of y, you find r equals, let me put y at this end, then you find 1 over p, then dq dx minus dp dy. And if you're able to get this as a function of y, then you put it into this equation of integrating factor, which is exponential r y then dx. So when you find the integrating factor, then you put it into, let me go back to the first part, then you use it to multiply your m and n, then you try to find if it is exact now. If it is exact, then you you continue solving. So these are steps, but we need to solve a lot of questions to be able to understand this. So you'll be solving questions that are exact, the ones that are not exact, that you need to use integrating factor. Then probably we'll be able to get examples where you need to test one. If it doesn't work, then you have to go to the next one. What I mean is you need to test with Rx if you're going to get the function as function of x. And if you're unable to get that, move to Ry and try to get your integrating factor from there. Easy to multiply the equation and solve your ODE from there. So, but you need to make sure your equation is in form of this for you to be able to use the exactness kind of formula, or let me say exactness kind of steps to solve your ODE. Yeah, so meet me in um, the next episode of this. I'll be solving questions on the exact ODE and the integrating factor. Hope you enjoy it. Thank you very much.